Lesson 57, finding exponential growth and decay. So an exponential growth model looks like this. It's a function of which is a times b to the x, and a is greater than 0 and b is greater than 1. So if your coefficient is greater than 0 and the number that's being raised to the exponent is bigger than 1, then it's going to grow and get bigger for each x. The exponential decay model, not mogul, model. Someone wants to be skiing. Is f of x equals a times b to the x. A is greater than 0, but b is between 0 and 1. So 0 is less than b is less than 1. So if your b is a fraction that is less than 1, but still positive, then it will be decaying. It will be getting smaller. Yes, sir?
Why can't it be negative? Because a negative exponent is just a fraction, right? Oh wait, never mind. The fraction turns it into like square root.
Okay.
Never
An
mind.
example would be if you're investing money, a equals p parentheses 1 plus r divided by n in parentheses all raised to the tn power. So a is the amount of money, p is your principal, r is the interest rate in decimal form, n is the number of compounding periods in a year. That's the one it is.
No, it's wait, that's not the principle of the school.
Yeah, it is. That's
It is.
That's what it says in the book. It's wrong.
You are wrong. N is a number compounding periods in a year. Compounding. So if it is compounded quarterly, then n would be 4. Or if it's compounded monthly, then n would be 12. And then t is the time in years. So if you're going to be doing 6 months, then the t would have to be 0.5, because that's half a year. So we're going to do an example here. We're investing money. The annual rate is 6%, compounded monthly. The principal is $2,000. And we want to know, after 2 years, what will be the amount in the account. So we just plug all this into our formula. A equals 2,000, parentheses 1 plus 0.06 divided by 12, all raised to the 2 times 12, or 24th power. And you would plug all that into your calculator. You do parentheses first, then you would do powers, and then you'd multiply by 2,000. and you would get $2,254.32. Yes, Carter?
Isn't the principal also just, could you call it the initial amount?
Yes. Yes. What you're starting with?
So what if you're compounding like all the time? Would you have to put like infinity? Like 2 times infinity, wouldn't that just be infinity? And then 0.6 divided by infinity.
We're not going there. The natural logarithm is a positive number x such that is the power to which, wait a minute, did I write this right? Oh, y is the natural logarithm of x. So if you take e to the y, and that equals x, then you can say y equals the natural log of x. So the natural logarithm is a positive number, x, is the power to which e is raised to get x. That is, if e to the y equals x, then y is called the natural logarithm of x, and the abbreviation y equals natural log of x. The value of e is approximately 2 718,000. So the natural logarithm is e, and that is approximately 2.718.
Shouldn't it be NLX, not LNX?
Is it what?
Shouldn't it be NLX, not LNX? It's not a log.
Nope. Yes.
Wait, so log, like L-O-G on the calculator?
Yes, and the natural log, you'll notice, I think, is in yellow. Possibly. Where's log?
Mine doesn't have the.
Oh no, it's just ln below it,
Oh,
below the log.
wait, so it's log, right?
It's a natural logarithm.
That's
Yes.
the L's of it.
I would like to show you some examples. So, yes,
So where did you get that number?
right here.
Yeah.
It just is a number that if you raise it to the y power will give you x. I don't know if that makes sense. It doesn't. And y will be the natural log of x. So,
So maybe if we do some examples, it'll make sense.
yeah. In fact, we might use our practice examples instead. But there is one more formula that you know, which is, or that you need to know, which is just simple interest. Wait, is that what it's called? It's PERT. You guys remember PERT, don't you?
Who?
How come it's not in my book? It's the amount equals probability times e to the RT. Have you guys seen that before? PERT. No? I swear we have. Okay, I am going to, I'll stop the tape and then we'll just talk about this stuff, because this is going to be, this is too confusing in the tape form.